So okay, let me rethink what I was saying. So yes, find out the Unix process ID using the top command. With the help of this number, go to the $v process and then find out the SID there. And with the help of SID, go to the $v session and find out the SID and the serial number. So you have to join these columns over there. And then you can find out, and then you can kill the session. Okay. So that is the next thing. Now the fifth question that I have. What are the three main components of SGA? What are the three main components of SGA? And the answer is very simple. The buffer cache, then the shared pool, and the redo log buffer. And now you also know there is one more kind of parameter here. This is that dbnk cache size. So now we kind of know one more area inside the buffer cache, and this is the library cache and dictionary cache. Okay, so these are the main components of the SGA. What information is kept inside the redo buffer? So this is redo buffer. What information is kept inside the redo buffer? That is the next question.
Old image, committed data.
Old image of data? Old image of data is not there.
Committed
old image.
Statement.
Log statement just
It's a redo vector. Okay. But old image of data is not there.
Old image of that executed statement.
How can a statement have one image and two images? It's a data which has two images.
It has both uncommitted transaction and committed image.
But it is a statement. I mean, a statement cannot have a old version and the new version. Statement is a statement. It has only one version. What you were probably talking about, maybe the older version of data and the newer version of data, which is not there in redo. No, it is only the redo vector, and which is what? Which means which means the statement. That is where you are correct. Statement is one major part of the redo vector, and then another two main things about the redo vector is the SCN number, at what time the statement occurred, and whether it's committed or uncommitted. These are the three main components of the redo vector there, which are going to be helpful during the recovery process. Now my question is, what is not stored inside the redo vector, or also what is not stored inside the redo log buffer? And that is select statements. Select statements are never ever stored inside the redo log buffer. So for a read-only database, there is a database can be read-only. So I think we have not seen this command, but we can say startup read-only. This is a SQL command to start up a database in the read-only mode. That means nobody can do any insert, update, delete activity, nobody can create tables and all that stuff, even if they have privileges there. So in this situation, what kind of things will go inside the redo log buffer? Not too much, because there is no activity. There are certain other things which are going, because behind the scenes there are certain activities that are happening, but entire database is in the read-only mode. So this thing will be very, very minimal activity on the redo log buffer there. So what is not stored inside redo log buffer is the select statements. Now the next question is, what are the two subcomponents of shared pool? And those are, what are the two subcomponents of shared pool? Library cache and dictionary cache. And what is the purpose of a library cache?
Stores the execution plan of this.
Stores the execution plan of all the statements, and select statements, insert, update, delete, all the statements. Okay, the execution plan of the select statements are stored in the library cache, and the purpose for that is when we do the parsing, or when Oracle does the parsing becomes very fast, because one of the major steps of parsing is to find out the execution. And then dictionary cache, what is the purpose of the dictionary cache? Whatever is in the system table space, which is basically data dictionary views, the blocks related to those data dictionary views are brought into the dictionary cache of the shared pool of their SGA. So that is the dictionary cache there. My next question is, what is a dirty buffer?
Modified buffer.
It's a modified buffer in in the buffer cache. So anybody who has modified this data, the modified data is dirty buffer. And it's just not modified. There is one small change, one small addition to that. It is definitely modified data, but modified but not yet written to the disk. That is what a dirty buffer is. So if I have modified this thing and initial value was 10, so let me draw a bigger diagram here. Initial value, when it was brought from the hard disk into the buffer cache, initial value of one of the rows in that block was 10. I have modified that 10 to 20. Before the modification happens, that 10 is, the whole block is stored inside the buffer cache. This is the undo, and then the new value is, let us say, 5. So this is the modified data, this is the original data, undo data. Both will be kept unless and until I do a commit. Once the commit is done, this is marked as expired. And then what about this block? This block is now dirty block because DBWR has not written that to the disk. Once DBWR writes this block to the disk, it is not dirty anymore.
Once it is committed.
Once it is committed, that doesn't mean that it is written to the disk.
Yeah.
Okay, so if it is committed, then it can be still dirty because it has been committed and then it is not written to the disk. So in a layman's term, what is a dirty buffer? Dirty buffer is something which has not been written to the disk yet, which is modified but not written to the disk. That is what a dirty buffer is.
Modified after commit.
Modified after commit means?
The block is modified but not committed yet.
The block is modified, no, the moment the block is modified, whether it's committed or uncommitted, because that's important information, correct? It is an important information. User may commit it, may roll it back. We don't care about that right now. But it is a block that is modified, and therefore it is valuable to us. We don't want to lose it, and therefore it is called as dirty. And what is the job of the DBWR process? To write dirty blocks from buffer to data block. So there is a process that we have not talked too much about. Checkpoint. Checkpoint is, as I said, it's a phenomenon. It takes some milliseconds. Checkpoint is a process in which all the dirty blocks are read from the buffer cache and they are returned to the data file. All the dirty blocks from the buffer cache are written into the data file. That is what a checkpoint process is. There are other things that also happen along with the checkpoint process, but this is one of the main thing happens. And now I will also introduce one more concept here, dirty list. What is a dirty list? Dirty list is basically list of blocks that are dirty. So block number, the buffer number 25. Actually, I should say buffer now, not block. Buffer number 25 is dirty. Buffer number 89 is dirty. All that list is basically a dirty list. In the older documentation, we used to call it as a dirty list. In the newer documentation of Oracle, it is called as a checkpoint list. Checkpoint list. So obviously, checkpoint list is a list of blocks that are dirty, and therefore checkpoint is a process in which DBWR will read this checkpoint list, find out which blocks are dirty, and will write them to the database block. And checkpoint takes certain time, maybe 10 milliseconds, maybe 15 milliseconds. It does take time. One more thing that I would again add, during that checkpoint process, whatever is written from here to here, the corresponding redo vector, which has modified these blocks, they are also written to the redo log file by the LGWR process. So let me repeat this thing. If the block is modified, it is modified because of certain statement. It is modified because of certain statement that is inside the redo vector. So a checkpoint is a process in which DBWR and LGWR, they are working together so that the information from these two is written down to the corresponding files. First, the coordination between them is done by the process called as CKPT. The coordination is done by the CKPT process. So CKPT process is like the main process. It will say, okay, let us do a checkpoint. That means let us save the information from the memory to the disk. So DBWR will be informed, LGWR will be informed. The very first thing that happens is that LGWR will write this information to the redo log file. So checkpoint process has started. First thing, LGWR is going to write the information to the redo file. Then the DBWR is going to write the information. They will coordinate between themselves. And once all this information is written about the dirty blocks, about the checkpoint blocks, checkpoint list blocks. Then we say our checkpoint is finished, and the last thing that happens in that checkpoint process is the CKPT process now is going to say, okay, we have finished the checkpoint at such and such time, that means at such and such SCN number. And that SCN number is written in the header of each data file. That is written in the control files. That is written in the redo files also. Everywhere it is written. That means at SCN number 4000 we have done a checkpoint. It means again what? In another way, it means that all the data that was modified before the SCN number 4000 has now been saved to the disk. All the data that was modified before the SCN number 4000 is now saved to the disk properly, and therefore you don't need to worry about any instance crash. I think we heard the word instance crash there. So that is what a dirty list, checkpoint list is, and this is what a checkpoint process is. Okay, now next question that I have, which process writes dirty buffers from the buffer cache to the data file? Which process writes the dirty buffer from buffer cache to the data file? The answer is DBWR. So that goes without saying. The next question after that, what is a checkpoint? I have just explained what a checkpoint is. Again, in layman's term, I will explain. Checkpoint is a process which takes certain time, certain milliseconds, and DBWR, CKPT, LGWR are working together to flush the data from the memory into the disk. Basically, one word, flushing the information or saving it to the disk. That is what a checkpoint is.
The blocks in these that buffer cache and RMB, the redo block buffer.
The information of the
Need to be modified.
so checkpoint contains the checkpoint is a mechanism. I mean, it happens that let us work together and write the information from buffer cache.
You are checking the blocks from checkpoint, right?
Checkpoint list.
Checkpoint list.
Huh.
The checkpoint list. It's not about comparing through LGWR.
No. It,
Coordination between LGWR.
no, there is a coordination. Coordination does happen. Let us say this block is dirty, and the number of that block is in my checkpoint list. So DBWR is going to write this block to the disk, but DBWR is telling the LGWR process that I am about to write this block to the disk, but you should make sure that you write the corresponding update statement also to the redo log file first. That update statement, that redo vector is written to the disk, then I will write this thing to disk. So always you will see this term in many documentation that redo writes first, or redo writes are first in the sequence, and this is a very difficult phrase to understand unless and until you have this whole background here. What do you mean by redo or LGWR writes first? It means during the checkpoint process, LGWR is going to write the redo vector down here, and once that is done, this is going to write it down here. Why does this thing happen? Because if this thing is written to the disk and this is not written to the disk and something goes wrong in that meantime, we have some data over here which is not correct, and we don't know that because it has not been written to the disk. We must know what is going to be modified and all that stuff. So writing to the redo log file is very important. Okay, that is what the redo